Alright, welcome back to the sixth video in this series where I'm covering Unreal Engine's character movement component in depth. Everything that I code in this video will be in a GitHub, which linked in the description, so definitely check that out if you want to follow along. And before I dive into the video, I wanted to talk about why you need this video and this series, because if you're trying to implement proning, you might be looking at this video and thinking that this is really long, and maybe you also don't want to dive into C++, which is what we're going to be doing. So you might not be sure that you want to click on this video, but I wanted to talk about why you need the character movement component specifically in your project. So if you haven't watched any of my other videos, basically the character movement component is an actor component, which is on the character specifically. And so you have to be implementing a character in your project. And this component is just obviously in control of all the movement of the capsule. It has to be a capsule. And so the major pros, so there's kind of two reasons why you would want the character movement component. And the first one is networking. So if your game is multiplayer, if it's co-op, if it's any sort of multiplayer game that's going to be on the network, honestly even LAN, then I would strongly recommend using the character movement component, because the character movement component provides client-side prediction. It provides net corrections. There's so many features here, and I speak from experience. I tried to implement this on my own without using the character movement component, and it was nowhere as good. It was thousands of lines of code. It was just not worth it at all. So I highly recommend that you would look into learning the character movement component if you're not familiar with it, because this will do all of it for you. I mean, it's literally what Fortnite uses for movement. So it's obviously certified by the industry, and it just takes the load of figuring out network logic off your hands and puts it in the hands of this kind of trusted system. Now, the second reason is that it's just such a good structure. It's just such a good architecture, I should say, because they really designed it so that sort of any movement you could possibly imagine can be categorized into these modes or abilities or kind of set definitions that the character movement component kind of facilitates. And yeah, I would say I haven't come across any ability or movement mechanic I was trying to implement that I couldn't do with the character movement component. And if you've been watching my devlogs, you can see that I have some pretty weird movement in my game. So yeah, it should be able to handle any of your movement, and it's just really it's really succinct. It really captures everything you need to do without making you write that much more code than is necessary, and it's all in one place, and it's all in these discrete little packages, as we'll see with the movement modes. So yeah, I highly recommend that you use the character movement component, even though it's going to require more knowledge in the upfront, more buy-in, and more code and C++. But in the long run, this is gonna be a lifesaver. So yeah, I just wanted to say that because I recognize that you can find other tutorials where they might implement proning in 10 minutes, and basically they're just messing with the capsule and changing the max walk speed. But that really isn't proning, because there's so many there's so many cases that doesn't work, and it really what I don't like is it just doesn't reflect how proning would be implemented, or any mechanic, in a real game with other mechanics. Unless your game is just a game that showcases proning, then sure, you could use a 10-minute tutorial. But if you want to actually know how to put this into a project as an actual game developer would, then you really would want to be using the character movement component and getting into the C++. So yeah, that's what we're going to be doing in this tutorial. That's what we've been doing in all our tutorials. And if this is the first time you're seeing this video, if you haven't seen any of the other videos in the series, then I would also strongly recommend going back and looking at them, because I really am going to build off what I did in previous tutorials. So we're not going to be coding the character movement component from scratch. We're not going to be starting with a blank script here. We're going to be working with stuff we've already done, and sort of also building off our knowledge. So at least I would certainly watch the architecture video, because that's where I go over a high level of everything that the character movement component provides, how it's structured, and just give you an understanding of how it works, which is critical to being able to write your own movement modes. So yeah, check that out. And also, like I mentioned, the GitHub is in the description. So if you don't want to go all the way back and watch them, if you sort of already know what the character movement component does, but you want to just get a feel of what I'm coding, check out the GitHub and you can see all that. You can boot it up in Unreal Engine right now. And so one other thing I wanted to mention is that I've also made some amendments to the code in terms of like the slide mechanic and the crouch mechanic. So if you're familiar with the other two videos or the other three videos, you've implemented sprinting, crouching, and sliding, and your code looks exactly like mine. Well, since those videos, I've been changing the code a little bit because my goal with this series and with this project is that I'm kind of just growing all these features from the character movement component from what we've covered, but I'm gonna edit the past mechanics we've made with knowledge that we've gained right now. So we're going to learn something new today about movement modes that I've kind of already applied to the slide mechanic as well as the sprint mechanic. So don't worry if your code doesn't look exactly like mine, and I will at the end of the video go over the changes I made to the other mechanics that we've implemented already. So yeah, if you're trying to stick along with exactly how I do all of this, then yeah, that'll be at the end of the video. So anyway, let's get into it. And first, I'm just going to talk about like what my pro mechanic is going to look like. So here's the guy, just very high level view. What I'm going to do is the player is going to have to hold C, and after they hold C for some duration, that's going to put them into the prone mechanic. Now, I'm not going to alter the capsule to be like a prone shape, so I could do some stretching with the capsule, or I could say rotate the capsule over. I'm not going to do that. I don't really think that's the scope of the character movement component. So if you look at how Unreal Engine implements crouching, the actual change in height in the capsule originates from the character itself. So the character movement component doesn't change the capsule height. I'm going to stick with that. Partially because it would also be a lot of extra code and it'd be too much to cover, but you don't really need to make the capsule fit the character when they're in proning. And you'll see this in other games, like often the legs in a character can clip into the wall or the body of another character when they're proning. It's not that big of a deal as long as like the head and the chest kind of can't go through the wall. So I'm not going to change the capsule size. It could easily be added to this video though. And yeah, so they're going to hold C, and that's going to put them in prone. If they enter a prone from a slide, so if they hit C once and they're crouching, and they hit C again, which would trigger a slide if they're going fast enough. But if they hold C on that second hit, then I added this cool thing where they're going to enter sort of a dive, and then that's going to go into a prone. So that's just like a cool thing I added. Not super necessary. I just added it to kind of utilize the other movement we've already been building on, so that I'm trying to make more interconnections, make the movement a little bit more complex and dynamic. So it's totally optional though. And if you're also thinking, if you're worried right now, like I don't really want to have C be the thing that makes my guy prone, or maybe you want a whole separate button instead of the crouch button, or maybe you don't want it to be triggered by a button press at all. Maybe you want it to be triggered by a certain zone the player enters. And I'm going to say for all those cases, so the way I try to break up each movement mode or each ability or mechanic in general is there's the implementation, which you can think of as the actual code that facilitates like the movement, the what WASDA does, just how the physics of the player will affect their capsule. So that's the implementation. Then there's the linking, which is sort of a part of the implementation, but that's making sure that this is compatible with the other movement modes, compatible with just the character movement component in general, and like a valid state the player can enter. So making sure all that works. And then the third part, which is the kind of the more optional part, is the trigger. And I define the trigger as sort of the thing that gets you into that movement mode. So that could be a button press, that could be a button hold, a double tap. It could be a zone that you enter, like a trigger, a literal trigger zone you enter, or something else. A cutscene causes it, just anything. And so the goal I'm trying to get across is that you could have a different trigger that's totally fine. In this video, I'm going to demonstrate another trigger other than the trigger I went over last time, which was a key press. So the C key is tied to a compressed flag. So this is going to be the first video where we cover a trigger that isn't a compressed flag. So that's going to be cool. That'll give you another tool. And yeah, so don't worry, you can do another trigger completely, but it will be important though to make sure that it is movement safe. And we'll look at that when we get to the trigger. So anyway, yeah, that's how I'm going to implement prone. So let's get into the code. All right, so here we are at the very top of our zippy character movement component. So yeah, we're just going to be working entirely in the character movement component today, just the same one we've been making all along. So the first thing we're going to do, since we're creating a new movement mode, is we're going to make a new value in our custom movement mode enum. So yeah, you're going to do this with every movement mode, and we're just following the syntax that we've kind of established here based off of how Unreal Engine's movement mode syntax is. And so next, we're going to jump right in and start with the mechanic and the actual implementation of that. So if you remember from the last video I did, I am going to start with the implementation, especially because that's kind of what we care about, and that's what pretty much everyone's prone code should look like, and also kind of what I'm specifically going to be teaching in this video. And then after, we're going to link the implementation to the system, and then we're going to establish the trigger. So implementation, link, trigger. So here it is. You can see it looks pretty similar to the slide mechanic. You got the enter, exit, the can prone, and then the fizz prone, which again, you'll remember, this is the actual function that's going to be called on a per frame basis that updates our capsule and actually creates that movement. So before we start implementing these, we're going to make some parameters up here. So these are pretty simple, I would say. We have the prone enter hold duration. We have the prone slide enter impulse. This is what I was talking about with that dive. So when you enter a prone from a slide, you're going to have this impulse that's going to be like a dive force almost. You have the prone max speed, which is just the speed you can move when you're proning. And then you have this braking deceleration proning, and we will look into this later. So if you already know what braking deceleration is, cool, but I'll explain it when we actually implement this. And yeah, like I said before, so you can see I've added some of this stuff to sliding, for example, the braking deceleration. And we're going to be learning about this in this video, but we didn't add this last video. But don't worry, because I will go over the amendments I made to the sliding at the end. But yeah, like I said, I just kind of want to build this pattern of implementing new tools like braking deceleration and then updating the entire project, because I want this project to really grow like I would think an official project would grow, instead of just being very only a tutorial and only sort of in an idealistic environment. No, I want this to be code you could refer to and think like, this is how it should probably officially be done, or at least this is how I would officially do it. So yeah, so now let's go right in and let's start with fizz proning. Alright, so this is a massive function, and similar to previous tutorials, I'm not going to code all this live from scratch because it's just too much and it would be a waste of time. So I'm just going to paste it all in here, and then we're just going to go over it pretty much line by line. And again, it really helps to have watched the last video, because I'm not going to go as in detail on some of the stuff that is common between the slide and the prone. Obviously, like before, we have this delta time less than min tick time. This just makes sure that we have enough time for our simulation to actually run a valid prone or invalid update. Here we're just making sure that there's a valid character. This is just like a sanity check. There's a valid character, there's a valid character controller, stuff like this. So here we are setting up just teleported to be false. This is another thing you kind of should always be doing, so that we know that in any of the future function calls, we didn't just teleport, basically. That's what it means. And then we have these variables. Before I go on, I wanted to say that, so this code right here is pretty almost a direct copy of fizz walking, And so that's kind of, it might sound like a cop out, but so the reason I did this is because, well, two reasons. One, because walking and proning are pretty similar. I mean, they're basically just a change in the movement speed and obviously an animation change, and a couple other like small things. But so fundamentally, they're not different, but more specifically, the fizz walking is like the pinnacle movement mode example. And so I really wanted to go over that without making sort of a useless tutorial where we just like look at the walking mode, since you already kind of have that by default. But I really wanted to still go over the fizz walking because it has substepping, which we'll look at in a second. And substepping is crucial to your movement modes. It's going to make everything more accurate, more reliable, and more predictable. And so this tutorial is going to be focused on how substepping works. And I'm doing it through proning, but I definitely want to highlight this because if you want to make any other movement modes, you should probably use substepping in them. And this is going to be where we learn about it for the proning case. So what we're setting up here is these are just some helper variables because to check like if we go over a ledge or if we are trying to do a ledge move, which basically means you're trying to move the capsule onto a valid floor, but the move you previously made like moved it over an edge kind of, but obviously we'll look into this more in a second. This line right here, remaining time equals delta time, what this is saying is that we are going to substep, and what substepping means is iterating multiple times in one frame. So we're given a frame, and a frame has a certain delta time, but we want to loop multiple times over that delta time to get a more accurate or a higher resolution simulation of the movement. This is a physics term, substepping, and not coincidentally, this is kind of a spoofing of movement physics. That's what I would consider the character movement to do. And so, yeah, we're going to set the remaining time equal to delta time, and then you can see right here, every tick or every substep, we're removing some of that remaining time for the substep. So that's what this is setting up. And then we have, this is the substepping, so this big while loop, and you can see it has a lot of sanity checking, just making sure everything's valid. And importantly, it makes sure that there's more remaining time than the min tick time. And if that's true, and if the iterations are less than max simulation iterations, so that's another important thing. That was defined as these iterations. So there's, I guess the reason why they make this iterations check is in case of like an infinite loop, in case you get stuck somehow. So you can only iterate a certain number of times, or at least you should only iterate in your logic. So if all these conditions are, if these conditions are met, we're going to substep. So obviously increment the iterations, set teleported to false again, because again, so this is saying that we didn't teleport with the current move, and since we're about to move the capsule, that move will not be a teleport, so we need to set that to false. Here we are getting the tick time, so this is just a function they made, just that way you don't have like a fixed tick time, you can get a simulation time step. So that's just like a helper function to get your delta time out of the current remaining time. Then you're going to subtract that off from the remaining time. Then we're going to make a saved value for all these old values. So the current base, the current base location, the floor, etc. And the reason we're doing this is because we might have to revert the move we just compute. So we're going to make a move, but we could have to revert it if we go over a ledge or something like that. And that's why we're saving the current values in the current state. Okay, next up, we are ensuring the velocity is horizontal. So this maintain horizontal ground velocity is a really handy helper function that keeps your velocity horizontal relative to the ground. Now you could be on a slope, you could be on a non-flat surface, but it'll maintain your velocity horizontal to that plane. And since proning is primarily a ground movement mode, this is just a helpful function to call. I'm going to store old velocity for reasons later, and we're going to zero out the z acceleration. So these two lines are different. This line is acceleration. So remember from last time, acceleration is the input vector. So you can think of it like it's the world vector of your WASDA. or your joystick, if maybe for some odd reason you're not using WASD or joystick, but basically those input vectors that you pass into the movement component, those are translated into acceleration and into a world vector of acceleration, and we're zeroing out the z component so that you can't move up, or you can't accelerate up or down. And the reason we're doing that is because calc velocity here, which we also talked about last time, applies the acceleration and it calculates the velocity. It also applies things like friction and this braking deceleration, which we'll talk about. And it applies all that to the velocity. So we want to make sure that no vertical acceleration is applied to the velocity in this line. If this wasn't true, otherwise we would get some vertical velocity if we had it on our acceleration vector. So braking deceleration, what is it? Braking deceleration is a handy distinction between friction. So friction is always applied to the capsule. So when the capsule is moving, there's friction applied to it, and that just always is slowing down its velocity. This way you can't just accelerate infinitely and just become, moving at insane speeds. So you have this friction holding you back. However, you want this ability to slow the capsule down when you let go of the controls. So like you're holding W, you're moving forward, you let go, you want the capsule to slow down pretty quickly. So that means you have to ramp up the friction really high. But then your movement will become slow in general, and you can't build any sort of momentum, say for example in a slide mechanic or any momentum you like, because your friction is so high to get that characteristic of slowing down when you let go of the controls. So braking deceleration is like a fancy term for like friction that only applies when you let go of all the controls. So when you're not applying any movement vector, you are braking, or if you're applying it in the opposite direction, you're braking, and that's what braking deceleration is. So that'll slow you down quickly, and we're going to have to define this because by default, and this is really annoying, by default, if you're in a custom movement mode, this function will return 0. So we're going to have to override this and return our custom braking deceleration, since we are in fact in a custom movement mode. So that's braking deceleration. And next up, we are going to compute the move parameters. So this is similar to before. If you recognize the adjusted, this is kind of the adjusted vector. So our move velocity is just a copy of our velocity. Again, this is kind of just the syntax that the phys walking uses. I don't know why they have to make a duplicate here, but they do. But I'm just sticking to their script so I can explain it. And this delta is kind of the target adjusted position. So again, this is a basic kinematics equation. Our dx is equal to v times dt. And so yeah, this is kind of the target displacement that we're hoping to move the capsule in based off of our velocity. That could not be the actual delta position after we've done all the movements, but this is where we're trying to move. And this is just checking, do we have no delta? So if the velocity was 0, delta would be nearly 0, and that would mean we have 0 delta. And if there's 0 delta, then we're going to set remaining time equal to 0. So what this logic is saying is if the velocity is 0, we don't need to substep over 0 velocity because the capsule isn't going to move anywhere. So there's no point in getting an accurate simulation if the capsule is just standing still. So we're just going to immediately set remaining time to 0 just to hurry up the simulation, just to finish it so we don't waste time in this while loop applying 0 velocity to our capsule. We're also making this step down result. This is going to be important for ledge stuff, which we'll talk about later, but we're just declaring this, and then we're going to pass it in as a pointer in this line. So if our delta is not 0, then we're going to move along the floor. With our move velocity, we're going to move a time tick, that's our delta time, of this substep, and we're going to pass in the step down results. So this is another super handy helper function. So far we've covered 3. We've covered this one. Calc velocity was also from last video. I guess this is kind of a helper function. And this is a super helper function. This does involve a safe move update component. So this line will move your capsule. None of these will move your capsule. like the name says, it moves you along the floor, and this is just really helpful because you could be moving on slopes of all different degrees, and you have like a different velocity, you have a different time tick, and you have this step down result, which we'll see. It's really important to know what surface you're on and what surface you're moving on to, because you can imagine, say the capsule's moving on stairs, then that surface is always changing, and we need to handle that accordingly. So this is going to help us get the results of whether we stepped off of a ledge, and we'll talk about the floor, which is something we're going to see later. But so yeah, just keep that in mind. We're just getting a reference to the result of what happened during this move along floor. So after this, again, like all of this is the build up to the move. This single line is literally the move. This is where pretty much your movement logic will happen 90% of the time. Everything else is sort of cleaning up that move. So the first thing we're going to say is, were we falling? So say we moved and we're now falling. We just moved off a ledge completely. There's nothing under the ledge. Now we're falling. If that's the case, then we are going to basically enter falling. And one of the cool things you'll see here is we're starting new physics with remaining time and iterations. So what this is saying is that we are going to start a new physics simulation, but with not the full delta time, but with the remaining delta time that we have. So you can see we're not missing a beat here. We don't lose out on any delta time, and we are going to switch movement modes mid-simulation, which is really cool. Like, if you design all your movement modes correctly, you could be walking off a ledge, and in one frame, you could walk off the ledge and enter falling, and even simulate a little bit of the fall with the remaining delta time. Technically, mid-fall, say you could enter a water volume and then start swimming. Like you can transfer between movement modes, and you'll just be using less and less delta time until the remaining time runs out. But this is neat. So we're starting this new physics simulation in the same frame. And yeah, this is just setting that up. Same case here for swimming. So start swimming kind of is a nice helper function that automatically does that for us. I don't know why they didn't decide to make one for falling, but here it is. So we start swimming. And I want to make a note here as well. So you can see this move along floor could have resulted in changes in movement mode, and we handled those edge cases. Now, you can always handle more and more and more edge cases. Like, there's just like, say you're making more movement modes, you got to add more cases. Like, what if we enter these new movement modes? There's always going to be more edge cases for you to handle. Like, what would happen if this is a nav bot, or just a million different things. And you definitely don't want to fall in this rabbit hole. This is what I started doing, is I fell in this rabbit hole of like, oh, I have to make sure everything works for swimming too. And then I was like, wait a minute, my game doesn't even have swimming in it, so why would I do that? So just make sure like it makes sense for your game. Like, you don't need this line if you don't plan to put swimming in. And it might complicate things. There might be some reason why somehow this line is triggering when it shouldn't, and that would make your code more complex, which is obviously not the goal. So I just want to make a note of caution before you like dive right in and make swimming valid in your game, even though it's not even going to be in the game in general. Anyway, moving on. Now, so that was handling the separate movement modes. If we accidentally enter a different movement mode, now we're going to handle all the ledge stuff. So when you're moving on the ground, you can walk off a ledge, but there's multiple cases here. So you could walk off a ledge, and the ledge is just straight drop, and you enter falling. You could walk off a ledge, and it's just a staircase, because a staircase is technically many ledges, and you want to snap the capsule back down to the floor of the next stair. So that's valid. You could step up a ledge even. That's valid. Or you could, say, step off a ledge, but maybe the ledge has another ledge really close to it, so there's just a tiny gap, and you want to move over the gap. So you don't want to fall through the gap if the gap's smaller than the capsule, obviously. So there's like a lot of edge cases here. And I don't even know the depths of all their implementations of handling these ledges and how this all works, but I do know enough to explain and to use this in my code, which I would say is a good balance because the character movement code is like 12,000 lines of code. Like you can't possibly know everything from scratch. Even the guys that write it are probably not completely familiar with everything. They probably only read their portion. So yeah, I would say you just got to be familiar with what you need, and in our case we need basically the code I'm about to explain. So the first thing we're going to do is we're going to update the floor like it says, and we're updating the floor using our step down result. So here's where we use this value because the step down might have computed the floor. Now what's the floor? The floor is just this super kind of useful struct here. I'll just show you. It's a find floor result, and this just gives us a couple things like if it's a couple booleans about if it's walkable, if it's a blocking hit, hopefully if it's a floor, the distance to the floor, the hit result, and then this F hit result will give you, if you're familiar with line tracing, this gives you like the actor, should be somewhere in here, the item, the object handle, which wow, so we're really getting far into it. This struct gives you a reference to the actor. It is here, fetch actor. So you can get the actor that you're standing on. And there's just a couple other nice things in the floor. So that's really useful. So we're going to set that to our current floor. Now notice this is blue, so I don't know if you use rider, but this is blue, meaning this is not a variable I just created. This is a member variable on the character movement component. So that's every time you see like a member variable like current floor or movement base, these are probably pretty important, and these are going to come up in multiple different occurrences in the character movement component. So current floor is just a nice struct that contains all the floor data about what we're standing on. And it's really only valid when you're using it in your movement mode, if you're actually updating it per frame. So like if you're not doing that, then you can't really, there's no point in referencing this. And here is where we're updating it. So we're just going to set it to the floor result if we already calculated the floor in our step down, but there's a case that we didn't. And if that is not true, we're just going to rerun this calculation. So this find floor will, do some line tracing, etc., and populate the current floor member variable. So once that's populated, we can proceed because here we need to do some important stuff with that. So we're going to check for ledges like it says, and first we're going to make sure we can walk off ledges. So if we can't, so you can actually toggle this in the character move component. It's a nice Boolean parameter that you can change, which is whether you can walk off ledges while crouching. So if you don't want to be able to walk off a ledge while crouching, then basically the fizz walking, and in our case also the fizz proning, will revert the move that you just made. So it just won't let the move, this function here, it'll revert that. It won't let it happen. So if we're checking for ledges and if the current floor is unwalkable, so maybe we just walked off a ledge like in this case, then we're going to calculate possible alternatives, like it says. So in this case, this would be like if we stepped off of a ledge and maybe there's like a space below us, or maybe there's a space to the left or right that we could potentially still get onto, like crossing a small gap. And that's what we're going to try to do here. That's what these alternative moves are. So we're going to get a new delta, and that's going to be get ledge move. And again, like just a helper function. You don't need to know all the specifics of it. And we're just going to try this delta. So if the delta is non-zero, we're going to revert this move, passing in all of our old stuff. Like that's why I mentioned we need these. Then we're going to set this try ledge move to true, so that we don't do this in the next iteration. And then we're going to revert, this is interesting, we're going to revert the remaining time. So we're going to add back the tick time. And we're going to set the velocity equal to new delta divided by tick time. What this is going to do is this is kind of reversing our velocity. So we have a target delta that the ledge move wants to do. The ledge move found a valid target to move to. And we know that we want to move to that target in our next substep with this function. but we can't set the delta here. We can only set a velocity. So we're going to set our velocity equal to the delta divided by tick time, which is the reverse of this equation up here. So it's v equals dx over dt, which is the opposite of, or not the opposite, but just the rearrangement of dx equals v times dt. So that is how we're kind of sort of getting around this, so that in the next update we move towards the ledge move, which will hopefully get us onto a valid floor in a new ledge. All right, so then if this is not the case, so if the new delta is still 0, then we're going to see, like I said, see if it's okay to jump. This check fall here is like a big helper function, which not only checks if you're falling, but actually puts you into falling movement mode if you are. So that's kind of what all of this is setting up, is it's just checking this massive fall. And if that's true, it's going to return, and otherwise it's going to revert the move and break and set the reign time to 0. So this is also kind of a return statement if you think about it, because we are breaking out of the while loop and setting the remaining time to 0. So yeah, this is just kind of the fall case. Else on this case, so what this else is referring to is this if statement. So if we can't check for ledges, and the current floor was potentially walkable, then we're going to go to this else case, and we're going to check if we're going to say, okay, so if the current floor was walkable, so maybe that means we stepped off a staircase. So the current floor is still valid, but like we are still technically walking off a ledge, but it's like a staircase or something. If that's the case, we want to adjust the floor height. What that's going to do, it's not going to adjust the floor height. It's going to adjust the capsule height relative to the floor. I guess you could call that the floor height. But yeah, this line will move the character. So I should have mentioned that. So the revert moves will move the capsule. Adjust floor height will move the capsule. Yeah, that's the only ones we covered that will move the capsule. So this line will move the capsule so that it is standing just right on top of the floor, right against the floor. Then we're going to set the base to the floor. Base is kind of confusing. We'll probably cover this more in depth in another video, but there's a movement base and there's a current floor. They're kind of similar. Like, I should probably look into this more, but the base is also like an actor that the character is standing on, and this is important for like relative velocities. So if the character is standing on a moving platform, the base is moving, we need to combine velocities, stuff like that. So we're just setting our base to that current floor, but I'm not entirely familiar with all the distinctions between the floor and the base. But anyway, moving on. Here, this other else condition, this is else. This is if the current floor maybe wasn't walkable, but maybe this check for ledges was false. So if that's the case, then, whoops, where we go? We're going to remove depenetration. So this means the floor, like it says, like the floor check failed because of penetration. So the capsule maybe was already in a wall. And we're just going to call this other super handy helper function resolve penetration. And that will clean all that up for us. So moving on, after all this gets executed, whether removed from penetration or whether removed from adjust floor height, we are going to again check if we're swimming and check if we are falling. So yeah, I guess you always got to do that, right? And check maybe for your other movement modes. Maybe you have a hang gliding movement mode where when the character steps off a ledge, they automatically go into hang gliding. You got to add that, right? So just checking for differences in movement modes. So after all that, so okay, this comes all the way up to this else case. So if I fold these blocks here, so this is all of the ledge checking. You do need this, you do need this to make sure that your character will have like gravity applied to them, basically. If this doesn't happen, basically pseudo gravity does not get applied. After all that, just this last little bit of cleanup. So if we're moving on ground, which hopefully we should be unless we change somehow, but yeah, I don't even think that's possible because we already return after our starting physics, but hey, this is how phys walking does it. So if we're moving on ground and all these are false, again, like a sanity check, then we are going to update the velocity. So here, I forgot to add this. This is saying velocity equals dx over dt. Similar to what I had before, but this time we're not trying, so we're not like doing any trickery. We're not trying to make the velocity equal to some target adjustment. We're saying the velocity is actually equal to the actual dx that we just computed. The reason for this is, I kind of said this last time, but if you're moving and you have some velocity and then you move into a wall, say, then your dx is going to be 0. Your dx wanted to be something non-zero, so it wouldn't fail, like it wouldn't say you have no dx. Your dx wanted to be something non-zero, but it hit a wall, so you didn't actually move anywhere. So we want the velocity to end up being 0 as a result of that, because obviously, like in real life, if you hit something, your velocity will be canceled out. And then after we update the velocity, we just make sure we call this maintain horizontal ground velocity, so that in some odd case where we move up or down, like say we step up or something, we want to make sure this stays to just be horizontal ground velocity, so that we don't have any problems with accelerating off of the floor because we're in a prone movement mode. And then right here, we're just saying if the component location equals the O location, so if we didn't move anywhere, then just set this remaining time to 0 and get out. So yeah, like it says, like iterations will be stuck potentially, so we're just going to abort. And then again, they call this if moving on ground, maintain horizontal ground velocity. This is so obviously this is redundant unless this case wasn't met. So for some reason, if you had one of these fail, they still really want to just make sure that's horizontal ground velocity. You could probably, if you don't, like, I don't really understand why they necessarily need this, but it's a little bit of a redundant check, but hey, they do it. I put it so that you guys can see how it should be looking officially. So yeah, finally, that is the end of the implementation. It's definitely a long implementation, but hopefully you learned a lot of important things. And again, like the main takeaway here is the substepping. If you didn't understand all the ledge stuff, that's fine, but know that you will get more accurate simulations from performing iterations at a lower delta t. So if you're just iterating over very, very small delta t, your simulation will be more accurate. And this is appreciable. Like you'd think, oh, like I'm already running 120 frames. So what? Like I don't need this. It's actually a noticeable difference. Like in my game, and if you've been seeing my devlogs, I have a sliding movement mode. And when before I implemented substepping, I was getting like these noticeable differences where I would enter a slide and sometimes I just have like this weird kind of almost bounce where I'd bounce out of the slide because basically my iterations were too rough. My DT was too large, and so I would move too far in one frame and I wouldn't be able to get a nice transition into a slide. And I'm not explaining it very well, but basically, like when I moved to substepping, I was getting, since I'm basically like doing, 6 times or however many times more simulations in one frame, I was getting much higher resolution simulations, and my movement algorithms were making the slide really smooth, and it fixed all those problems. And I was thinking there was some bug in my logic, but my logic was fine. It's just that the simulations were too coarse. So yeah, like you could probably get away with it without doing substepping, but it's definitely worth the extra effort, especially in an important thing like proning or walking. If it's a one-off mechanic, I get it, but I would definitely make sure you can understand and work with substepping. So yeah, that is the prone implementation done. Everything else will be linking and finish. Well, we have to finish a little bit of the prone implementation, but mostly just linking that to the system and implementing the trigger. So let's go back here and check what else we need to do. I guess first we'll implement can prone. All right, so yeah, this is really easy. Basically, we can prone if we're sliding or if we're walking and crouching. Not much of a surprise there. This is the two movement modes which we can enter proning from, and specifically we have to be crouching to, if we're walking, to enter the prone. All right. Next, we're going to do enter and exit. So these are also not too complex. For enter prone, we are going to force wants to crouch to true, because we want to maintain that smaller capsule size in proning. And then if our previous mode was sliding, then we're going to add this boost to our velocity. So we're going to do prone slide enter impulse times the direction of velocity and add that to velocity. So this is just adding an impulse, and that's that dive I was talking about. So again, this is a little bit gimmicky. Like, you don't have to add this, but like if you want to have a sort of dive boost, so if you enter a prone from a slide, that's like that dive, and that'll give you a little extra boost, which I think is a cool mechanic, but completely unnecessary. Then we're going to call find floor. So we called this, you'll recognize this from fizz proning. The reason why I'm calling this here is because if I open up the fizz again, what this is going to do is this is going to set our member variable current floor. The reason I'm doing that is because if I come down here and go right to this move along floor, this is going to be called every move. This is the move we want to do. But if we look at this implementation, the first thing it does is it checks if the current floor is walkable or not, and if it's not, it returns. So if you were in a movement mode that didn't populate current floor, or I think even just if you're switching movement modes, sometimes this will be like not updated to the most recent value. This will return, and you'll have like this will not move the character. Now, obviously, right down here we will update the current floor, but I just want to be proactive and update the current floor so that technically the very first substep of the very first frame of proning will have a valid move. Like, you could get away with this because the floor will be updated immediately after the first move, but the first move will fail. And you know, if we're doing things correct here, we should make it so that even the very first move has a valid floor so that it can validly move the capsule. So that's enter prone. Exit prone is literally nothing. I'm doing exit prone only for like to follow kind of the pattern I've created with my movement modes. So you can see, like, for sliding, you have the enter exit can and then the fizz slide. So I'm just following that pattern. Not necessary at all, really, but I like it to keep the system like this so that I can chunk up the logic more easily in my head of what's happening. So now that is the prone implementation done. So, you know, if you just want to see how I did prone, you're just curious how that works, proning is done. Now we're going to link it to the system. So I guess actually you should definitely obviously stick around for this. But we're going to make sure that this new prone movement mode, which we just created, is properly linked and valid for like other functions we've declared, just as a valid state in general. Like, I guess the idea with this part of this process is that if we were to somehow be in the proning movement mode in our game, would the code fail? Would there be some runtime error or just some logic error? So we're going to fix that in the linking step. So the first thing we're going to do is we're going to go to is moving on ground. This is a function that we override this function last tutorial, I believe, because we want to also add that if we are in the slide movement mode, we are also technically moving on ground. And it's no surprise that proning is also a ground movement mode. So we're going to add another case where if we're proning, we are also moving on the ground. Okay, next we're going to go to our fizz custom here, which this is the function that is called when you're in a custom movement mode, and then it's your job to differentiate between your custom movement modes and call the appropriate fizz function. So we obviously have to add our case here for proning. So if our custom movement mode is equal to prone, then call fizz proning and break. So yeah, like as we get more and more movement modes, this is just going to be duplicated down the line. So yeah, that's we always have to put this for new movement mode. Next, we're going to go to on movement mode changed. So this is whenever we enter a new movement mode, and we're going to add the calls to our enter and exit functions. So let me format this a little better. So like this. So if our previous mode was proning, then we're going to call exit prone. And if our previous mode was, or if our new mode is proning, we're going to call enter prone. And if you are following along from last video, this is one of the amendments I made. So we'll take a look at this at the end, why I kind of switched around. But yeah, we'll just cover this in the end. But so this is what I have to add for now to call these functions I declared for enter and exit. So now we're going to come back to the header file, and we're going to implement some more functions. We're going to override some more functions that we want to add special cases to for our new movement modes. So they're going to be sort of this same like helper getter functions. So get max speed and get max braking deceleration. They kind of fall in line with these functions where they're they're usually kind of getters or like just helpers that are usually probably like movement mode specific. And so yeah, we'll start with max speed. So I'll paste that here, and we can see the first thing. Well, we'll skip this line for now. I'll come back to this, and this is another amendment I made where I'm switching around the sprinting logic that I made from the very first video. But don't worry about this line if you're not like strictly following with the tutorials. This line is just saying if we're not in a custom movement mode, return the super, because the super will be valid. If we check this out, the super is valid for all our default movement modes. So that's valid. And you can see actually there is this case for the move custom where it does return this max custom movement speed. Now, like you could just have one max custom movement speed for all your custom movement modes. I obviously don't recommend that if you have more than one. Or you could change your max custom movement speed when you enter a new movement mode. But then you have to keep track of changing this. Like you might forget to change it, and then that might break things. What I would instead do is override this function and then have a switch case on all your custom movement modes. That way, if you forget to implement a custom movement mode, then you'll get like a fatal error, and you'll remember, oh shoot, I didn't make sure to update my max speed for that specific movement mode. And again, so I just do the prone max speed and the slide max speed. And these are the speeds at which you move in these modes. They're called max speeds because you have to accelerate to get to them. So you could be traveling at a slower speed, but this is typically like the movement speed. And I'm noticing that I did prone max speed, but here I did max slide speed. What is the convention? It is max first. So should be max prone speed. My bad. All right. Next, we're going to do braking deceleration. So also pretty simple. Similar pattern here. If we're not in a custom, let the super handle it. And if we are in a custom, just switch case over the custom movement modes, and fatal error if we did not pick up any of those cases. Yeah, pretty simple stuff. And so that concludes the linking for our character movement component. There's many, many more of these like little helper functions, right? And they are probably, some of them will probably be invalid for some of my movement modes because I haven't gone through, all thousands of lines of the character movement component and defined and overridden each of these helper functions. Here again is where I'm talking about like being like implementing too much. So like there's probably some function like get max distance, etc., that will break in my movement mode, but I don't need that function. So I'm not going to override that function to implement it for my movement modes until I actually need it. We do need this one. We already talked about how we need braking deceleration. We do need max speed because that's going to affect our calc velocity when we calculate the velocity, basically. So this is called in that function, calculate velocity. So now we're done with that, and we can move on to the trigger. So let's go back here to the header file, and I'm going to show you a new trigger. So in the past, we used a compressed flag, but a compressed flag, so first off, you only get 8 of them, and 4 of them are reserved by the default character movement component, so you really only get 4 for your custom stuff. And I don't like that. I want to, I want a lot of movement mechanics, but I don't want to use a flag for every one. And proning is a good example because you don't need to tell the character movement component, or I guess you should say, you don't need to tell the server every single frame whether or not you were proning, because proning is more of like a one-off event, you know? Like, I can see sprinting, because sprinting you're pressing on and off, like potentially, you know, on and off every frame or something, and you can be entering and exiting the sprint mode sort of. But proning is sort of a one-off thing, you know? It might only happen every couple seconds at maximum. So we are going to do an RPC linked to a saved movement variable. So that's a new trigger. We're going to be covering it right now. And I'm going to show you how it works sort of in general so that you can implement it for any variety of abilities, mechanics, and modes. And it's really, I would say it's really helpful for abilities. Anything where it's like a one-off trigger that you enter and it has like a maximum duration so that you know, you can't be triggering it like 100 times, because it is going to use a server RPC, a reliable RPC. And so you don't want to be triggering this often. So yeah, let's get into that. So the first thing we're going to do is create a new, not a flag, sorry, a new variable on our saved move, right? This is our saved move underscore zippy. So it's going to be, no surprise here, wants to prone. Again, it's not a flag. If you don't know like what I'm doing here, if you don't even have this class, or you just don't know about the safe movement system and movement safety, then definitely watch my architecture video, and at least watch my setup/sprinting video, because first off, I set up all this, the character movement component and this stuff, and I give you an idea of, you know, what this means, why I need to have this, you know, what is this saved wants to prone, you know, what is this pattern I'm doing right now. And so yeah, that's what I cover in those videos. So if you don't know what that is, watch those. Anyway, you'll remember that for every saved variable in our saved move, we need a safe movement variable. So let's come down here and add this safe wants to prone. So this is the working variable. This is the variable that we're like legally allowed to reference in our character movement component. And it's going to be swapping in and out with this variable, the saved one. And real quick, we also have to make this saved movement variable valid with our system, which basically really just means defining it for set move 4 and prep move 4. So let's come back to the C++ file and jump into the saved move and open up set move and prepped move 4. So we're going to add this line, following the same syntax, just populating the saved value with the safe value. And then this line, just exact opposite, populating the safe value with the saved value. So yeah, hopefully you should be really confident with understanding what I'm doing there. So next we're going to come back to the header file, and we want to add some functions down in our prone implementation that are going to actually change the value of that variable. So we're going to implement these two functions. So try enter prone is simply just going to set wants to prone to true. The reason why I'm making it a whole function is because we're going to have to call this from a timer handle. So we need to have a function callback. We can't like make a lambda for that. And then this is the RPC. So server enter prone is the client is going to call that, and that's what's going to cause proning on the server. But we'll see how we set it up in the sort of RPC plus saved move context. So let's implement these two. So you can see it's painfully simple. It's literally the same thing. It's literally just saying wants to prone is true, because all this, again, this is just the trigger. And like I said before, like this, so everything we've set up until now is pretty much valid for any ability / movement mode that you want to trigger with a RPC plus saved variable. So the reason the system works is because, think about it, we have this safe variable, and the client will do something that will trigger this. So the client will call try enter prone. They'll flip this variable, and then they also have to call, so we haven't called it yet, but they also have to call server enter prone. And that will also flip the variable on the server, because that's all it does. So we flipped these two variables. Now it's safe, meaning that it'll get stored into the saved move at the end of every move, and that means if we have any replays, if we have a client update call, so if you remember the architecture video, if the client is adjusted, then that value will be preserved and the proning will still work even in the replay. So that's why it needs to be safe. That's a very important part, by the way. And other than that, now we have this link so that the server and the client both have this variable toggled to true at the same exact time. And one really helpful tip about server RPCs is that when they're called, they will always arrive before the current frame of movement RPC arrives. So you'll always get this, like this RPC will run on the server before the frame corresponding to the frame that was run on the client ran. If that makes sense. So like the client runs, say, frame 100 of movement and sends an RPC. That RPC will arrive exactly on the move before the server runs frame 100. So it's really helpful to update your state variables right before that. Obviously, if you have some sort of packet loss, this could run on the frame after, 2 frames after, or something like that. That's an edge case. You'll have a desync, but that is obviously unavoidable. You're going to have desyncs when you have packet loss, but you definitely want it to be reliable, because you don't want the server to miss a prone state. Like, it's okay if it's a frame off, you'll have some slight hiccup, but you want it to at least be delivered. So that's why it's reliable. So this is the general trigger implemented. Now we're going to specify how we actually call this function, how we actually are going to activate the trigger in our specific implementation, and how that trigger will actually affect the movement component, namely entering the prone movement mode. So we are going to make another transient variable up here, a timer handle. Like I said, you're going to enter proning after holding down the C key for a specific amount of time. So we need a timer handle. This is obviously not movement safe, right? Because time is running at different rates on the server and the client. But it's okay because only the client is going to be calling enter prone. Is going to be running this timer handle, because only the client has information about the C key actually being pressed on and off. So we are going to call that in all the way down here, crouch pressed. So we're going to say, we're just going to set a timer, and we're going to give the callback for try enter prone. That's why I had to make it a function, because we need to have this callback so that it actually runs a function. We can't just do some sort of lambda or inline here. And the in rate is that enter hold duration, which we can change in the editor. And yeah, we just get back this timer handle that we can use as a reference to this timer. Next, we're going to go back to the header and add another function. This is another interface function, so we're probably going to be calling this from blueprints. This is crouch released. We need the released case now. We didn't need it before, but we need it now, because if they let go of that C key, then we want to cancel the timer so that they don't enter that slide. So let's implement that. Super simple stuff. Just clear that timer. So this is just getting the timer manager and removing the timer by referencing the timer handle. So hopefully you've used timers before. If you haven't, just check them out on Unreal docs. They're really simple. They're just a handy way of calling a function after a duration of time. So now we have the trigger set up, activated, and like the mode of triggering it, it's completely replicated. It'll trigger on the server and the client, but doesn't do anything. This value, we're writing it a lot, but we're not reading it. So let's read it. So the way that we are going to use the trigger to enter proning is similar to the crouching and sliding. So we're going to come to this update character state before movement, and here we have like for entering sliding, here we have for exiting sliding, and basically we're going to do the same thing. We're going to say this is the enter prone case and this is the exit prone case. So if wants to prone is true, and if we can prone, then we're going to set the movement mode to prone, and if we are not the server, we are going to call server enter prone. So pretty simple. Hopefully this just, makes complete sense what we're doing here. Regardless of whether we can prone or not, this is important. So regardless of whether we can prone or not, we're going to flip back wants to prone to false. Now the reason for this is because if this is not flipped back to false, then this will keep running until we somehow can prone. But you only, so basically this wants to prone value will be false, 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 false. As soon as that timer is triggered, we have X duration, like we've held C for long enough, it'll flip it to true. And then the frame after that, we're going to check this condition. And if on that frame we can't prone, then we're not going to prone at all, ever, until you have to press C again to indicate you want to prone again. This just helps so that if you're holding C while, say, jumping, you won't somehow enter the prone immediately after coming down from a jump or something like some weird edge case like that. So yeah, this will happen on the server and the client, and you'll get this nice synced up behavior of this variable, meaning that this logic will run at the same exact time, and yeah, it'll be super clean. The exit case is even more simple because you only need to just tap C to get out of a prone. You don't need to hold it. So remember, C is kind of coordinated with this wants to crouch boolean, similar to wants to prone. It's just, except this is an actual compressed flags variable. So this is updated every frame, and we're just saying if we don't want to crouch anymore and we are in the prone movement mode, then just set your movement mode to walking. That just gets out of crouching, or gets out of proning. And then we'll call the super, because again, like I said before, like we want to handle this variable before the super is called, because the super will also do stuff with this variable, and we want to just get the value of the variable before the super messes with it. So yeah, believe it or not, that is all the code to implement proning. That was kind of a long tutorial. Sorry for making it so long, but I really wanted to go over in detail like how I was doing some of this stuff, and especially the explanation of the fizz proning, which is essentially fizz walking. I really wanted to cover that, even though it's, you might say it's kind of a cop-out because it is essentially just fizz walking, but I just wanted to explain it because I think like understanding the fizz walking is really important, and understanding that substepping, because there's some helper functions and some logic in here that you wouldn't necessarily just know to come up with on your own, but it's pretty important for getting really accurate movement, such as like, the movement in Fortnite and stuff. So, I certainly wouldn't have just thought to implement substepping right off the bat, but after seeing how they did it and seeing their setup, this makes a lot of sense, and I've implemented very similar patterns in my game. So let's jump into the editor now and see how this all works. Alright, so here we are in the editor, and off camera I did whip up some animations just so that we can visualize what the character is looking like when they're proning and stuff, but again, like that's not in the scope of this tutorial. This is purely about movement and not about like the visual representation of that movement, but it is really interesting, I still think, and I really like doing the movement animations, but they're pretty coarse for this video, just really rough stuff, just to give you the visualization. But before we jump into it, we have to make that call to crouch released. So again, like our our implementation up here is very simple. In the blueprint level, we are just calling these basically button presses, calling our implementation. This is not supposed to be accurate of how like I would do it in a real game. This is just because we're not making, this isn't a demo on an entire game, right? This is just a demo on character movement components. So the character movement component is how I would do it. The what calls these functions, the button presses and whatnot, I would certainly never have a blueprints with a hard-coded key press like calling this, but for demo purposes this is fine. For the parameters we made on here, so you can see these prone parameters. I already set values which I think are good. So like these durations, these impulses, the max speed, and the braking deceleration. But play around with those to get the values you want. So yeah, let's go ahead and check this out. Let's first just show it on one player. Here I am. I press C once. I'm going to crouch. You'll be happy to know that I did add a crouching movement animation from the disgusting one from last video, so looks decent. And then you can sprint around, you can slide from last time, and now if you hold C, you crouch, or you prone, sorry. And I added this kind of basic movement animation. It kind of looks like the character is sliding along the ground. It's not, I'm not selling the prone exactly. If you are thinking like maybe you wanted a prone that had this intermittent movement, like you can see how the character looks like they're moving in these increments where each time they're lifting their shoulders up. And if you wanted that sort of behavior to be actually affecting the capsule, so let me real quick show you what the capsule looks like while this is happening. You can see the capsule is not moving, and it's just kind of staying in roughly the center of the chest. I don't recommend trying to actually make like realistic motion with the capsule. Like, don't rotate the capsule over. Don't make the capsule move in these like intermittent bursts of movement, sort of like a real human would, because that's going to complicate things unnecessarily way too much, and it's going to cause, especially like rotating the capsule, it's going to cause network problems, going to cause more desyncs. Try to fake all this stuff with animations. Like, okay, sure, you get like this, like I could fix this, I could rotate the head, I could push the body farther back in the capsule, or I could just make the capsule wider, like when you enter a prone. And you have like the legs can clip into stuff, but you can adjust that with capsule width, and you can adjust that with the relative position of the mesh inside the capsule. But please don't like try to tip the capsule on its side in proning. That would just be a nightmare, and it wouldn't be necessary for like most games, I think, unless you're really trying to be hyper realistic. So yeah, there's the proning, and then like I said, you can also do that sort of dive. So if I'm sprinting and I double tap and then I prone, you can't really tell, the velocity is kind of low. Maybe if I had it coming at the side, you can see you get a little extra velocity from that dive, and I just thought that was cool. Obviously, if I was trying to sell this in a real game, I would add a separate animation for that dive so that you really can feel that oomph of velocity. But I thought that was just a cool thing to add to link some of the stuff we've done in previous videos together. So yeah, obviously also the other big test is test that networking, right? Because that's what we're here for, right? So 2 players, my VRAM is going to kill me again. So here we are. I can crouch and I can prone, and you can notice the animations are synced up. So if I go on the server and do this, you can notice that the client can still see the server in the prone animation. The reason for that is because the movement mode and the custom movement mode are replicated, which is really nice, like just a nice handy feature. Like obviously that's how it should be, but it's nice because like I'm not writing any custom networking logic to make the client see the animation state or anything like that of the character. The animation is all offline, but because the movement mode is triggering and like that set movement mode is firing on even the remote clients, I'm able to see the state of the server on the client, like with complete detail and accuracy because of the replication there. So no, like that's part of the thing I mentioned in the architecture videos. Very, very minimal support is needed for you to get simulated proxies up and running, because on the client the server is a simulated proxy, right? So anyway, just testing this out on the client. So if I sprint, double tap C, there's the slide. If I go into prone, you can see there I am proning on the server. I can do a dive. So if I come over here in front of the character, oops, that was completely off camera. Do it right here. There's my dive. Not much. I should probably increase that velocity. So yeah, everything's looking good. Let's just emulate a bit of packet loss, or not packet loss, packet lag here. Let's just jump right to 500. So there's super laggy, but lo and behold, everything seems to be in order. So yeah, sweet. That's proning. Another cool thing I want to show you guys that I was experimenting with while making this is I was emulating packet loss. That's when you literally just lose packets. So the parameter here is a percentage. So like 100 is full packet loss. So here I move, but literally nothing happens because no packets are making it. So it's completely offline. If I change this to say like 10, which is still a horrible value, but like maybe possible, you know, it's good to test your code with this. Like obviously packet loss is very unideal in any case, and you will have desyncs, you can't prevent that. But like here, let's go ahead and also turn on p.net show corrections. So that's going to show, see these lines that are appearing? These are every time that they're basically, in our case, because our movement logic is sound, these lines are appearing because we have desyncs from packet loss. But this is also a helpful way to debug other movement modes, because these corrections will happen if your logic isn't movement safe. So you can get packet loss that results in these hiccups, and you'll see if I try to make a big hiccup here. Yeah, you see that stutter? That's from packet loss. But if you write, and you can see sometimes I wasn't even prone. You can see sometimes I was triggering that slide and it wasn't happening. That's also from packet loss. But if you write bad movement logic, you'll also trigger desyncs. So this is a good way to debug. I show net corrections always when I'm debugging movement code when I'm writing my movement logic. So just a helpful thing to have on. There's also, like, you can change how long they're shown for, I believe. Yeah, show correction lifetime, net correction lifetime. That's just nice. Like if you want it to be really high, so that you want to keep those lines forever appearing, so you can like study them. What's happening here, right? Like the red line is showing where the character was, the green line is where they were corrected to, and the yellow lines, I believe, are frames that were resimulated. So you can see the correction was very minimal, and we didn't experience a massive hiccup. But on some of these, the corrections are pretty severe. And then all those yellow lines are moves that are valid, but they've been resimulated because of, you know, how the network client prediction works, which I talked about in the architecture. So yeah, hopefully you should be comfortable with like the resimulation of old moves using that saved move struct. So that's what's happening here. So yeah, I went really in depth in this video, like really combing over everything. Sorry, it's definitely really long. I haven't edited it yet, obviously, but I think it's going to be massive. So hopefully you learned a lot from that. Hopefully you stuck through it to the end, and are confident that you can implement this and more of your own movement logic in your game. And then before I wrap it up, I'm going to go over the amendments I made from the previous videos. So that's this section. So let's close this up. So first off, for sprinting, that was one of the very first videos. I changed how we're doing that. So previously we were using the on movement updated, and we were adjusting the max walk speed. You know, you could do it like that. That's honestly fine. But I there's once we implemented this function, which I didn't want to implement right off the bat, but once we implemented get max speed, I wanted to add this little case. So this is just a little cleaner, I think. So it's if is movement mode walking and wants to sprint, and we're not crouching, then we're going to return the max sprint speed. Otherwise, if this case was false and you were walking, you would return the max walk speed. Now, the reason why I like this method a little bit better is because this way I'm not changing max walk speed, because max walk speed is really a parameter that should be constant. The speed at which you walk is just a fixed speed. The speed at which you sprint is an entirely different parameter that should also be constant. So I don't want to like edit these values that should be constant. So that's why I'm using the get max speed function to override that. It's a weird case because this is like the one case where you have different max speeds in the same movement mode, but this is how I'm handling it. I think it's just a little bit cleaner. Next, we have the sliding stuff. So sliding was the first movement mode we created. So the first thing I did is, here we're going to the slide implementation. I completely overhauled the fizz sliding to use iterations, and it has a little bit of my custom logic in here because sliding is a little bit different, but I completely overhauled that, and it's still pretty similar to proning because they're still pretty similar, but I do stuff like change these. I have this slope force parameter for moving faster down slopes, and I project acceleration, like stuff you'll recognize from last video. I also did finally fix this. This was annoying. We're not supposed to be in a fluid. The difference is that when you're in when this is true, I think friction is applied like a lot stronger. So now I'm still using ground friction, but I'm using a slide friction factor, which I think is way cleaner, so that you can move onto surfaces with larger friction, and that'll be reflected in the slide, but it's still a friction factor, so that you don't have the full ground friction applied, because that's way too much friction. I do some other stuff. This is mostly standard ledge checking stuff. I'm no longer updating the rotation of the capsule to be snapping to the surface of the slide, because that's unnecessary. Try to not rotate the capsule as much as possible. Yeah, look at the GitHub to like really review this, because I don't want to go over it too much to make this video too long. I also cleaned this up, the can slide, so I have fizz, enter, exit, and can slide, which just tests if there's a valid surface and if you have enough speed. Then I don't, so if you remember from last time, I made enter slide, and we call enter slide, and that will set the movement mode to sliding. Oh, that's a remnant. My bad. We don't want to set the movement mode in enter slide. We want enter slide to be called by on movement mode changed, this function. So this way you can simply just call the set movement mode function, which is a default function that's already in the character movement component. You don't have to call the custom enter slide to get into the slide. The reason for this is because two things. One is just, I think it just cleans things up, because these enter and exit functions are automatically called by you. You can be, say, calling set movement mode in blueprints. You don't need to have this exit slide exposed in blueprints, but it'll automatically call the enter and exits for you. And two, because you might exit a slide and you might enter a fall, or you might enter walking, or even swimming. So I didn't want the exit slide to set your movement mode, because that's making assumptions about what movement mode you're entering. And the other main benefit is that I can call this exit slide before the enter slide. So I have this nice order where I call the exit before the enter, so that you can just clean up, like say on the exit you need to fix the capsule rotation, which you're already assuming is fixed on the enter. So still a cleaner way of doing things, and it really just tightens up the implementation of a movement mode to just be this tiny little discrete chunk where this is where the action happens, and these are just a couple of tiny helpers. One last change I made was for the sprinting. I just added this little compressed flags enum. I figured I'd do this because if I look at the character has, oh, well, it's really long. Compressed flags, here it is. They have this enum, and they have their flags named for their character movement component, and they just have custom 0, 1, 2, 3. And I was looking through the code and I was like, oh shoot, like that's kind of annoying to just write custom 0 everywhere, because like what does that mean? So then I said to myself, okay, you know what, I'll just take these flags and redefine them for really the only flag I'm using right now, which is sprint. And I'm not actually redefining this when I say that. I'm just defining the compressed flags for the custom cases, so that you'll see if I go to the usage of this. Now I can reference saved wants to sprint is result or equals flag sprint instead of custom flag 0. It has no use other than readability, but for completion I wanted to add that I did change this. So yeah, finally we're done with the video. Oh my gosh, it's probably gonna be the longest video yet. Thanks for sticking to the end. In the next video, I'm probably going to do, I've gotten some recommendations for a dodge mechanic, or like I'm probably going to do something that's not a movement mode, like an ability. Something that's, yeah, just like a one-off action. If I don't do that, I might also do like hang gliding or wall running. You know, there's a lot of movement modes that I can still cover. And I also have to at some point cover root motion, because it's a rare thing, but I think you guys are out there that really want root motion. So and also root motion sources, those are really cool. You probably have no clue what that is. I had no clue what that is, but it's useful. A root motion source could be used for like if you want to say when you enter like a melee, and it like, you know, like in Battlefield 5, like when you do a melee and you do like a takedown and you kind of get locked into this animation, but the animation of you locking into the character could start from like different angles and whatnot. So it's like a fixed movement path, but it's sort of so it's like halfway between an animation and a dynamic movement. So that's a root motion source. But that'll probably be later. So yeah, one of those is coming next. If you have an idea of what you want to do next, definitely leave a comment, and I'm not trying to plug here, but I actually want to know what you guys want to do. So, you know, if there's some topic that you really want to cover for character movement component, definitely like comment it, and I probably will do it. Like I did this video for proning because people wanted proning. So yeah, thanks for sticking to the end, and I'll see you in the next tutorial video or devlog. So yeah, see you guys later.